Hello everyone. In this video, we are going to discuss about the exercise question 3.7 of class 11 physics from the chapter motion in a straight line. Let us go through the question first. Two trains A and B of length 400 meters each are moving on two parallel tracks with a uniform speed of 72 km/h raised to -1. Okay, so there are two parallel railway tracks. A is moving with a speed of 72 km/h raised to -1. B is also moving with the same speed along the same direction. So let both are moving in the along this direction, that is to the right, with A ahead of B. That is, you see, A is ahead of B. Okay, that is B is actually behind A. Now the driver of B decides to overtake A and accelerates by 1 meter per second square. If after 50 seconds the guard of B just brushes past the driver of A, what was the original distance between them? So you see, suppose initially B is somewhere here and A is somewhere here. It is given in the question that A is ahead of B. So that is why I have taken A somewhere here. So you see, there is a certain distance initially between A and B. So you see, A is here but B is here. So there is this much separation between A and B. That is, this is the original distance between them. I am taking this original distance between them as initial distance between them as x. We want to find out this x. Okay, here I am considering the trains, both the train A and B, as point objects. See, we have already discussed about this point objects in exercise question 3.1. So here I am considering these two trains A and B as point objects. Now let us consider the train A, the case of train A first. Okay, see, it is given in the question that both the trains are moving with the same speed. Alright, so you see the speed of A, that is the speed with which A is traveling initially. I am taking it as U, or you can take it as V0, which is 72 km/h. We know that this 72 km/h is what? 72 into 5 by 18 meter per second. Okay, so this will be equal to what? 18 4s are 72, 4 5s are 20. So 20 meter per second. So initial speed or initial velocity V0 is equal to 20 meter per second. Okay, you see, A is moving with a uniform speed. There is no acceleration for A. So acceleration of A, I am taking it as 0 meter per second square. Now I am taking the time as 50 seconds. What will be the distance travelled by A in 50 seconds? Let us just find out the distance travelled by A in 50 seconds. So you see, we have this equation now. To find out the distance, x is equal to V0t plus half A t square, or you can use the equation s is equal to ut plus half a t square. Both are the same. So this is equal to what? V0, which is 20. So 20 into 50 plus 1 by 2 into a t square, half a t square. But acceleration is 0. 0 into any value will give you 0. So plus 0. So this will be equal to what? 5 2s are 10. 2 more zeros. So 1000 meters. So you see, 1000 meters, it is the distance travelled by the train A in 50 seconds. So suppose after 50 seconds, the train A has reached somewhere here. So the distance from the initial position to this final position. Now let us consider the case of train B. It is also moving with an initial speed V0 equals 72 km/h, which is equal to 20 meter per second. Okay, and you see, train B accelerates by 1 meter per second square. So its acceleration is equal to 1 meter per second square, or 1 meter second raised to -2. Then I am taking the time as t equals 50 seconds. So what will be the distance travelled by B in 50 seconds? I am taking the same equation, x is equal to V0t plus half a t square. So here x is the distance travelled by train B in 50 seconds. So this will be equal to what? V0 into t. V0 is what? 20 meter per second into time is 50 seconds plus 1 by 2. Acceleration is 1 t square, that is 50 square. Okay, so this will be what? X is equal to 20 into 50, which is 1000, plus what is 50 square? 50 square is 2500. Okay, then half, 2, 1 2s are 2, 2 2s are 4, 5 2s are 10, 0. So 1250. Okay, so x, which is the distance travelled by train B here, which is equal to, when we add these two, we will get 2250 meters. That is in 50 seconds. Train B, which is initially here, in 50 seconds, it has travelled 2250 meters, and suppose it has reached here. Okay, so that the guard of B just brushes past the driver of A. That is, both reach at the same positions but on different parallel tracks. We want to find out this distance x. How can we find out? You see, from here to here, the distance is 2250 meters. From here to here, it is 1000 meters. We want to find out this x. That is, we want to find out this distance. So that will be what? 1000 plus x, that is actually equal to 2250. Okay, so we can write 1000 plus x is equal to 2250. So x is equal to 2250 minus 1000, that is x is equal to what? 1250 meters. So the initial distance between the train A and train B, that is the original distance between train A and B, that is equal to 1250 meters. So in this video, we have discussed about the exercise question 3.7 of class 11 physics from the chapter motion in a straight line. I hope it is clear to you. Thank you.